Hey students, sorry I can't be here today for science. I'm hoping that this little video clip will help you get along with your assignment task without me for the meantime. So we're working on, hopefully we've got our tables of data, and we're going to move on to the graphing stage. Now if you don't have good results, let's say things, you tip them over or they went missing or something like that, and you weren't able to get a complete set of results, then what you can do is you can download a copy of this file over here particularly. You can find this on the Firefly page underneath term 4 classification topic. Mrs. de Villiers has very kindly uploaded her results that we can use if there were students who had trouble with their plants. So another thing that might occur, before I move on to the graphing bit, if you have some issues on your spreadsheet here, I might be able to help you out a little bit, but you may need to have your teacher specifically have a look at your spreadsheet to see if there's any other problems in it. But what we should be seeing is nice numbers here in the average column. So I've made it so that you can't edit anything you're supposed to leave alone. You're not supposed to put any numbers in here, so I lock them out as well. So the only thing you should have been able to do is to put results into these little blocks here, and you won't get these averages here are programmed to calculate for you. If you're getting some errors or something like that, then what you'll need to do is that you probably have somewhere in your results, you may have like written in millimeters inside of these individual entries. I'm going to call them cells. You have to remove all letters from your numerical results. Otherwise, the program will not understand. It'll think that you've written a name of something. So you need to erase all evidence of letters that you may have used. Other things that may go wrong is that, let's say plant number 8, 9, 10. Let me just use a different color here. Let's say plant number 8, 9, 10 never actually sprouted for the lamps. Then don't put zeros in here, just leave them blank, okay? So these entries all the way down, if they never actually sprouted at all, then you just leave them empty. That will preserve the accuracy of the averages. Okay, let's say plant number 5. Let's say at this point here, it died. Then what you might do is you might copy and paste the most recent, entry and just make sure it's carried across in all the further rows down below. Because if it is dead, then we should theoretically see either no further increases into its plant height, or maybe even a little bit, maybe it shrinks a little bit. I don't know. I'm not that great at plant growing, to be honest. Maybe they shrink when they're dead. Who knows? Okay, so hopefully you have some really nice averages. Right, moving on. We're going to make a graph, and we're going to graph this data. And the data is going to be based upon this and these, okay? Now, please do not try and graph every single one of, don't graph every single one of those. You will go mad. We set this experiment up deliberately such that we have more than one plant to work with so that we can calculate an average. And that's what these columns here are made for. These averages are done so that we can sort of take out a little bit of the variance that normally happens when you collect results. So for example, if you're doing a cross-country training and you want to find out what's your how long does it take you to do a particular trek, a course, then you might do it a few times and calculate the average, because sometimes you might be a bit quicker, sometimes you might be a bit slower, but you want to find a really good middle number. And average is one of the most basic things that we can use with a calculator to try and find a really good middle number. Some plants may have sprouted really well and very quickly, and some sprouts may not have grown very much or very quickly. And so when we do an average based upon all of those, we get a really nice middle number for that condition. So whether that's in the lamp or whether that's in the cupboard. Okay, let's scroll on. So your graph should look something like this. You need to have a title. Let me just switch to a highlighter rather than circling everything here. I'm going to pick orange. You need to have, that's not even a highlighter. Let me choose pink. I like pink. You need a graph title. It might seem a bit dumb because there's only one graph, but when you get to older grades, you will need to, you may have more than one graph to work with, and so it's not necessarily intuitive what graph is which. So you need to give them a name so we can tell them apart. So give it something that you think makes good sense. You also need to have your axes named. Because again, if you just have numbers that go down here across the bottom and numbers that go up here on the side, they don't necessarily mean anything unless you tell me which, what those numbers correspond to. Are we saying that these numbers that go up the vertical, are they measured in days or is that the time? I'm not sure unless you give me the name of the axis. Okay, so once you've named your axes, you also need to provide the units. So we are going to say, let's say this one here is plant height. Then what are those measurements made in? If somebody's looking at the graph here, they may not know if you intended these to be shown in centimeters or in millimeters. So you need to specify what unit you have chosen for your data so we can all make sense what's happening on the graph. You need to do that for both axes. So this one here and this one here. All right. You might be thinking, all right, well, which one goes here and which one goes there? I've given you a bit of a clue here on the diagram. The bottom axis, the horizontal, is the independent variable. Okay, and in our experiment, we had a few variables going on that we were trying to test. We were just testing light versus dark. So you might sort of consider that to be, we could say the whole thing there is amount of light. Okay, that's one variable that we were working with. We got plant height. And then we also had time. Now, traditionally, the independent variable is the one that you deliberately changed up so that you could see what interesting things will happen. So the ones that we were changing is that we actually changed this one. We didn't change the time. We didn't change the plant height directly. The only thing that we actually changed was the amount of light that we gave to the plants that we were trying to test. So you might think that this one goes here. Well, you would only have like two categories, light, dark, and that doesn't really make a lot of sense. So most cases, this one here is independent variable or it's time. So in this occasion here, I think time makes the best sense to be put on the bottom axis here. So you're going to put time down here. What about your vertical axis? Which one are we going to stick there? Well, that's going to be the plant height. We want to basically see the differences in plant height over time. So this one here, plant height, would go into that column here. Now we've got how do you show the light versus dark? Well, that's what this whole legend business is. You can show that using the legend where you use a different symbol. You can use X's, crosses, plus signs, squares, circles, or you can use different color pens if you want, as long as we can tell quite easily which one is which. So you would have maybe one of them, let's say X's represents the light, and let's say the triangles represent the dark, or the cupboard ones. Okay, hopefully that gives you a clue what to do. Now with the, before I move on, you know what, I'll just bring up the worked example down below. So let's scroll on. Okay, so here I've started to build a graph. I've left a few things out. Fill them in. So the bottom axis, time. So I've given the bottom axis a name, but I haven't provided the unit. So let me just stick that one in. So the measurement of time is that we measured it in days. numbers on my scale. For the horizontal scale, I basically need to cover the entire range of time. So what's the smallest value of time? Well, that would be 0 days, wouldn't it? And the highest number of days that we had measured, let me go to the spreadsheet and go look that up. Well, it looks like 26 was the largest number of days that we were measuring for. So let's put 26 here. Okay. If you have, if let's say your plants died off, then you could probably just trim off the bottom section where every plant is dead anyway. So you might choose that 19 could be your biggest number. So Debelius kept on measuring them all the way to the very end. So I can use all the way up to 26. That's why I've chosen 26 here. And it's just a process of doing all those increments. For the vertical axis, what's the lowest number of plant height? Well, that would be 0 millimeters, wouldn't it? When they were just seeds lying in those little containers. What's the highest value in height? So I need to make sure that here I fit all my data down below. So I need to find the highest average plant height. Let's go looking for it. Usually it's going to be towards the bottom of the graph chart here. Let's see, 20, 30, 32, 35 is probably the biggest one here. The ones in the cupboard, looks like they went as high as 40, 50, 60. Looks like we're about 65.2 on average. So we need to have a graph that reaches at least more than 65.2. So what I would typically do is I would round. I typically find that these things here are really convenient if you go up in either ones, so 1, 2, 3, or I find that it's pretty handy if I can go up in 5, so 5, 10, 15, depending what you need, okay? So I would round up to the nearest, or the next multiple of 5 upwards. So if our highest plant height was 65.2, then to round this up to the nearest multiple of 5, that would be 70. If I use 70 as my maximum, then everything else should fit down below. So that's what I'm going to do. Trying to find and make this 70 up here, and everything else here will be down below. And then you would have to figure out whether you want to go up in 5s or 1s or 2s or so forth on the vertical axis here, which I'll go further into detail in a moment. Okay. So I've got my scales, I've got my axes labeled, I've got my units, I've got my legend, I've got my title. Now it's a question of plotting the results. So let's just make, I'm going to make these ones up, okay? I had some questions that, from students where they, I could hear that they wanted to find out how many days it has been without weekends. And I was trying to tell them, no, leave the weekends in your results. You have to trust me. If you remove the weekends from your time, then your results on the graph will look weird. They won't look the way they should. Okay, so typically there's 5 days in a week. So I've got 5 crosses here. Okay. And then there's usually 2 days for every weekend. So there'll be 2, and you can see that on the spreadsheet that I built for you guys, is that I deliberately left 2 rows representing the weekends, and I made it so that you couldn't write into those. I locked them out so you couldn't do anything with them. You need to leave the results in there. You need to leave those empty gaps. So let's say there's let's say this is the weekend, and so my data continues on. Actually, it might be a little bit more growth than that, perhaps. Okay. Now, if you leave the weekends, then you can connect the results and it makes sense. However, if you remove the weekend, then you're effectively squishing the data like this. And now, instead of looking like a normal natural growth in plants, it almost makes it look like you skyrocket every so often on your graph, which doesn't look like reality. Plants don't suddenly surge like this every 5 days. Okay, so you need to leave those empty blanks on your on your graph. Otherwise, it'll look weird. And then, of course, you'll have your cupboard plants, which might be performing a little bit better. Okay, and so on and so forth. Let's scroll down. I do want to talk about, you have a choice. What orientation are you going to use to make your graph? Well, I find that if you hold the page vertically, you get more vertical resolution. So for example, well, we know that our vertical axis is the plant height, the average plant height. So we can use that if we're finding that our results varied a lot and we need more resolution into the plant height, then we might use this orientation for our page. If, however, you saw more variety or more range in days, you get more resolution on the other axis. So you need to make this choice. Both will work. You may find that one works better for you, depending on what the experiment is, depending on what you're trying to graph. I don't know off the top of my head right now. It might be something you want to try out for yourself with some pencil and paper and see how you go. Now, you will need to figure out how big are you going to make your graph onto that page. You need to make the graph as big as possible on that piece of paper, okay? It's not really any good if you make a graph like this big on the corner of your page. That's not showing that you've done a good job. It's harder to discern things on your graph. It's like trying to make sense of a photograph that is really, really tiny, okay? It's not that helpful to try and look at a picture that's really, really tiny on a page. You want to make it as big as possible so you can make out all the details. Same thing with signs in our graphs. Make them big. So you then have to try and figure out, well, how am I going to fit my axis on the page? Well, what I typically do is I count how many boxes there are vertically, and then I'll see if, so let's say there is, I don't know, 25 boxes high. Okay, I need to fit in 70 millimeters on that axis. So can I do, what if I did, if one box equals 2 millimeters, will that reach 70? So let's see. Well, basically, I need to double this figure, so I would get 50 millimeters. So that's not quite enough. Okay, so maybe I need to modify that. What if I did one box equals 4 millimeters? Will I get to 70? Well, 25 times by 4, so 25, 50, 75, 100, so I'll get 100. That could work. So I could do that, or I could do one box equals 3 millimeters. And I think that'll be the sweet spot. So 3 millimeters, 25 times 3, that gives us 75. That will be really nice and close to this figure. So it might be a little bit longer than I need, but that's okay. I'm gonna burn some of these boxes down below because I need to fit in the word for my axis label. So that might work out just fine for me. So that's one way of working things out. Another way of doing it is to go by 5s or go by 2s or go by 10s and count up manually. That's another way of doing it. Before I end the video, a question that comes up is, a problem that comes up is that there is usually somebody who asks, can't I just make this on the computer? And While in the real world, when you're out there doing a job for a living and you need to make a graph, of course you're going to use the computer. However, we are in the school system, and the reality is that when you get to the older year levels, so grade 11, grade 12, you will be doing exams where they will ask you to plot the results onto a graph in an exam. That means you have to do it by hand on paper, and you're not going to be quick enough unless you've had some practice. And it may be the case where you have to do this on an exam, maybe not so far into the future. Maybe you have to do it in year 8, maybe you have to do it in year 9. So we are looking for that skill. Can you create a graph by hand? If you're that one student who shows up with a printed copy from Excel of a graph and everything's all beautiful, then we have a problem because you haven't done what we have asked for. It's on the task sheet. You need to be able to do this thing by hand. So please, please, please don't be that student who disobeys the task sheet. It's not great, okay? It is hard work, and I can see why you would want to do it on a computer. However, it's a skill, and we need you to be able to learn this one. So please make sure that you do these by hand on some paper. So you could use your maths books, but you were supposed to have like a little book at the start of the year with some grid paper on it that you can tear out pages from. If not, maybe somebody in your class has some spare paper they can hand out around. But I hope this is enough to get you going on the task of graphing.